Question 1a, write down all the factors for 15. So, how do we present our answers? Okay, let me show you what I saw. Okay, so this is part A, and then the student moved on to part B. Part B was 28. And so on and so forth. Okay? So, anything wrong with this? What do you think? Is there anything wrong with this? Question 1a? Shu Yi, can I have some comments for question 1a? If this is presented? Please stand up. What do you think? Okay, she said that if you present it this way, you are not writing out the answer. Look carefully at the question. Write down all the factors. Where are the factors? I only see that in this question, in this working, thank you, Shu, you can sit down. 15 equals to 1 times 15 equals to 3 times 5, so on and so forth. But what are the factors? So what I expect will be factors of 15 are 1, 3, 5, and 15. Okay? So once you have this, take your green pen, put a tick. Because over here, this does not show, this does not tell me directly what the factors are. Okay? Next thing, one more mistake is that I see 15. Okay, so without all these things, what I saw was 15. Okay, what is wrong with this now? You look at, if you read this, 15 equals to 1, 3, 5, and 15. Is that true? Is 15 equals to 1? Is 15 equals to 3? 5? It is only equals to 15, right? So if you put it this way, this over here is definitely wrong. Because if anybody were to believe this, I will give you $1 and you will give me $15. Since they are the same, right? But it cannot be. Nobody will make such a deal with me. So we cannot write something like this. Be very careful with what you use. Okay, so this is wrong. What about 15? What about this? Look at this symbol over here. When do we use this in mathematics? We use it for ratio. Okay, so let us reserve this for ratio. But sometimes, some of you may present your answer this way. Answer, then with a colon, 1, 3, 5, 15. Okay, this is fine. This one is okay. Because I understand that this is telling me the answer is as such. Okay, this one is okay. But this over here, 15 is to 1. Okay, this one I do not accept. Okay? So I am very particular with what you use for your working. What you use for your mathematics. Okay. Next one, question number 8. Determine whether the following numbers are prime numbers. Recap, what are prime numbers? Prime numbers are numbers with only two factors, 1 and itself. So is 1 a prime number? 1 is not a prime number, because the factors of 1 is 1 only. Okay, I need two factors, 1 and itself. 1 and 1 not counted. Okay, so the smallest prime number is number 2. Now, for 8a, 103, how do we determine whether it is a prime number or not? We start to divide. Can I divide this by 2? Can I divide it by 2? I cannot. What about 3? Can? Cannot. I keep going on and on and on. I realize that it can only be divided by 1 and itself. Okay? So this is a prime number. 103 is prime. We do the same for part B, and now we come to part C. 817. 817, is it a prime number? So we need to start to divide it again by all the different primes. And I keep increasing 13, 17, and then I go to 19. What is 817 divided by 19? And I get 43. Right? Now, over here, I know that this is 19 times 43 already. This means that okay. Any questions? The final question I want to go through is 19. Express them in index notation where the bases are prime numbers. So 12 times 15. Instead of using our calculator, take 12 times 15 and then get 180. And then you do this. Instead of doing this, there's an easier way. Let me show you the easier way. Okay, so 12, you get 2 and then 6, divide by 2 again, you get 3, 3 and 1. So 12 is equals to 2 to the power of 2 times 3, right? So this is for 12 over here. Then I multiply this by 15. Okay, and 15 I have divided by 3, get 5 times 3 times 5. This is 15. Okay, now, is this easier? From here, I will have 2 to the power of 2 times 3 to the power 2 and multiply by 5. Okay? Okay, let's try something that looks a little harder. Let's try part D. 33 times 60 times 125. Okay? So let's see what 33 gives us first. Divided by 3, we get 11. Divided by 11, you get 1. So this is 3 times 11 for our first number. And then multiply this by 60, right? So 60 divided by 2, you get 30. Divided by 2, 15. Divided by 3, 5. Divided by 5, we get 1. So this is 2 square times 3 times 5. This is in green. For you to see clearly the relationship. And multiply by 125. 125 divided by 5, yes. I get 25 divided by 5 again, I get 5 again. And I get 1. So this is multiplied by 5 to the power of 3. Let me use purple color to show you that they are equivalent. Can? So all the blues they are equivalent, green are equivalent, purple are equivalent. Now with all this done, can you tell me what is the final answer? Which factor should I write down first? So usually we like to keep things neat. So I write down the smallest factor first. The smallest prime factor, which is 2. Okay? 2 to the power 2. Because this is the only time where I see 2, isn't it? Okay, let me cancel it off so that I don't confuse myself. I cancel with a pencil first. Okay, which factor should I try next? 3. Okay, 3 to the power of 3 to the power 2, yes. Because there are 1 3 over here, another 3. So 3 to the power of 2. What is the next factor I should have? 5 to the power of 4. Okay. Over here I have 1 5 and then another 3 over here. So total there are 4 5s. That is why we have 5 to the power of 4. Am I missing out one factor? Yes. Times 11. Okay. So this is what I have as my final answer. I do not have to multiply them out to get a gigantic number. And then I start to and then I start to do my division. It's very tiring. This way is easier. Okay? Now question. If you did it like me over here, but instead of using a pencil to cancel things out, if you didn't use a pencil, instead you used a pen, this is what you end up with, right? Then when I look at your answer, then I see, oh, 33 times 60 times 125 equals to nothing. Then it gets confusing, right? It may confuse the teacher, it may confuse yourself. So to keep things neat, for this kind of thing, cancellation, so on and so forth, please use a pencil. And I'm just using a red color pen to show you that I am trying to use a pencil. Okay? Okay, are there any questions that you want me to go through in exercise 1.1? Any other questions? Okay, then please file away your exercise 1.1. If there are no corrections to be submitted, if there are any to be submitted, please do the corrections. Submit them by when? By tomorrow. Okay, next one. Please take out your part 2 of your notes. We have not finished with LCM. We last stopped at exercise 11. Who does not have your notes with you? All have it, yeah? Okay. Now exercise 11 is your homework. Who didn't do your work? Anybody didn't do? Now you are seated in your pairs, right? Can you just look over at your friends' work? Just check that they have done it, and they have done just check that they have done it, okay? Now, I'll go straight into the question. There are two numbers. They are written as product of their prime factors. Find the smallest integer, the largest integer, which is a factor of both a and b. What do you think the question wants? Largest integer, which is a factor of both a and b. So they wanted the highest common factor. So instead of us doing this, 4 times 9 times 5, and then we get 180 over here, and then do this 4 times 27, 108, and then we start to find, 180 equals to 1 times 180 equals to 2 times 90, so on and so forth. Then you list everything out, the factors. Instead of doing all these factors of 180 equals to 1, 2, 3, so on and so forth, then you compare. Very tedious. We don't need to do all these things like what we did in primary school anymore. Okay? We don't want to do all this. We don't even need to find out what they are equal to. Whether it's 180 or whatever, doesn't matter already. Because there is an easier way of doing things. Okay? So what is the highest common factor of A and B? We just group out all the common factors. So HCF will be equals to, what are the common factors that we have in A and B? 2 to the power of 2. So write it down. 2 to the power of 2. Any more? Any more? 3 to the power of 2. Yes. Times 3 to the power of 2. Because these are the common ones. Now from here, I will evaluate. 4 times 9 is 36. You all get that? Okay? Part B. Find the smallest integer which is a common multiple of A and B. This gives us the LCM. In LCM, we want to have all the factors. And this is what we should have. 2 square times 3 cube times 5. So this will be 540. Do you all get this? And finally, for part C, find the smallest positive integer value of n for which this over here is a multiple of b. In other words, what this is telling us is this is a multiple of b, right? So b is a factor of 2 square times 3 square times 5 times n. Okay, this is what the question is telling us, yes? Sorry? Can you please come over? Where's your color pin? So, b is a factor of all these, right? Can we check? Now, b over here is 2 square times 3 cube. Let's check if all the factors of b are found here. Okay? First one, 2 square. Is it found inside? Yes, it is found inside. So nothing to change. What about 3 cube? Is 3 cube found inside here? Yes or no? Is it found inside? No, right? We only have 3 square in 2 square times 3 square times 5 times n. I don't have 3 cube. What is missing? What am I missing? I'm missing a 3. So what do you think is the value of n? This n must be equals to 3. Okay? So in part C, n equals to 3. If you have that, please put a tick. If you don't have it, please do your corrections. Make sure you understand why you got it wrong. Can? Now exercise 12, similar type of question. Part A, HCM. Between the two of them will be common, take out all the common factors. So we have 2 square times 3 to the power of 4 times 5 times 7. Okay, and we have to express our answers in index notation. So I do not need to evaluate. This is my final answer. Okay? In part B, smallest common multiple, which is the LCM. This will be equal to 2 to the power of 4 times 3 to the power of 6 times 5 square times 7 to the power of 7. I do not need to evaluate. This is my final answer. Alright? Any questions? Okay, now we have problem sum. Two best friends, Peter and George, they are working together at the shop today. Peter works once every 15 days. George works once every 6 days. How many days do they have to wait until they get to work together? You understand the question? Do you understand the question? You must first understand the scenario. Okay? So let's say today is Monday. Both of them work together. Are they working tomorrow? No, right? What about Wednesday? No, right? But after 6 days, then George will work again. But his good friend Peter is not working. So he doesn't get to see his good friend. Now, after 15 days, Peter comes to work. But is George working? George is not working. Doesn't get to see him. So when do they get to see each other? We are trying to find the lowest common multiple over here. Okay? So 6 equals to, let's find the lowest common multiple. 6 equals to 2 times 3, and 15 equals to 3 times 5. So LCM okay. So this gives me 30. Number of days equals to 30. This is what we should have. Can? So this is important. If you left your answer as LCM equals to 30, no marks given. At least from me. Okay, no marks given because I don't know whether you understand fully what 30 represents. Okay? So number of days will be 30. Let's move on. Exercise 13. Bread rolls are sold in packs of 48. Chocolate bars in packs of 150. So in one packet of bread, okay, hang on. So over here we have 48 bread. And then in one packet, we have 150 bars. You either buy 48 pieces of bread at one time, or you buy 48 times 2, which is 96 pieces of bread, so on and so forth. You either buy 150 bars of chocolate, or you buy 300 bars of chocolate, or you buy 450 bars of chocolate, so on and so forth. Okay, you cannot break it up. Now, John buys the same number of bread rolls as chocolate bars. So, in the end, right now we do not know how many packets of bread rolls this person bought. We do not know how many packets of chocolate bars that this person bought. But we do know that finally, when you count all the individual bread rolls, all the individual chocolate bars, they have the same number. Okay? So, find the least number of packs of chocolate bars that he could have bought. What do they want from this question? Is it a HCF or LCM? They want the LCM. Okay? So, if I were to draw it out for you, this person bought 48 bread, 48 bread, I don't know how many he bought. 48 bread. And then he had 150 bars, 150 bars. All these, they are equal. Right? Finally, they have the same number of pieces of bread, the same number of pieces of the chocolate bars. Sorry, 150. Okay? So, this over here, this is 48 times, maybe let's say there are X number of packets. Over here we have Y number of packets. 48 times X. Over here I have 150 times Y. And these two values, they are equal. So, in this case I have a multiple of 48 is equal to a multiple of 150. In other words, they want the LCM. Okay? So over here, equal. Let us find the LCM of these two numbers now. 48 is equals to 2 to the power of 4 times 3. And You don't have to erase this off, but I need some space. 150. Wow, so fast. Okay, 150 will be equals to 2 times 3 times 5 square. Am I correct? I hope I'm correct. And now we will need to find the LCM. This will be equals to 2 to the power of 4 times 3 times 5 square. Okay, what does this number represent now? What does this number represent? Ayman, what do you think? What does this number represent over here? Sorry? This number, 1,200. Number? Okay, this is the number of chocolate bars. Number of chocolate bars. Let's see. Jiahui, do you agree with Ayman? This is the number of chocolate bars. 1,200. What is it? Oh, and the bread rolls, okay. Which is equals to the number of bread rolls. Yes, both of them are correct. Since they're the same number, right? So, have I answered the question already? No? What am I missing? Yes, these are the number of chocolates and the bread rolls, but the question wanted number of packs. So, number of packs. What is the answer? 8. Right? Any questions? Okay, next one. Exercise 14. There are 3 lights. They flash at regular intervals. The first light flashes every 12 seconds, the second one every 27 seconds, and the third one every 90 seconds. Okay? Different timing, they will flash once. And they all flash together at, do you know what this time is? Over here? 9? Is it 9 a.m. or 9 p.m.? Chris?
I think it dropped somewhere.
Gwen, bring it back to me. This is 9 a.m. Quickly, your recess is coming already. So this is 9 a.m. At what time do they flash next together? What do you think? The question wants. Yes, lowest common multiple again. So 12, express it as index notation, 2 square times 3, 27, 3 cube, and 90. We have 2 times 3 square times 5. LCM will be 2 square times 3 cube times 5. This is 540. What does this represent? Anybody? The number of seconds before? Yes, this is the number of seconds before they all flash together again. Okay, let's change this to minutes. How much is that? Thank you. 9 minutes. So this means that every 9 minutes, they will flash once. Okay? What is the next time they will flash together then? At 0909. That's it. Okay, now there are 3 more questions. Please try them yourself. Bring them next lesson. Just 3 more and we are done for part 2 of the notes.